This presentation will be about cyanotypes. After seeing a New York Public Library exhibition called Blueprints, the Pioneering Photographs of Anna Atkins last fall, I became fascinated by this photographic process. I believe this will not only be instigating for my own curiosity, but it also is a relevant subject to share since this photographic method is still being used today and works using this technique may be incorporated into collections under our care. The cyanotype process was invented by the astronomer and chemist John Frederick William Herschel and presented to the Royal Society of London on June 16, 1842. Color changes of solution of iron salts were noticed as far back as the 1700s, and the inorganic pigment Prussian blue, which is the image-forming material of cyanotypes, has been used since 1730 as a pigment in oil painting and watercolors. As soon as Herschel's experiment with cyanotypes were announced in London in 1842, an assistant librarian at the British Museum named Anna Atkins would embrace this technique and be responsible for creating the first ever published book illustrated with a photographic method. Atkins was brought up with most of the tight-knit British scientific community of the early part of the 19th century. Her father, Dr. John Children, was a highly respected scientist and secretary of the Royal Society. He started his career as an assistant librarian in the Department of Antiquities. His wife died from complications of childbirth, which created an unusual close and permanent bond between father and daughter. From an early age, Anna Atkins applied her drawing skills with a careful attention to scientifically accepted standards of accuracy. Atkins' patience, dedication, and attention to visual details were clearly evident in shell drawings she created in her early 20s and were fundamental skills for her future cyanotype project. In the 19th century, it was common to issue books in paper wrappers, so the owners could choose their own bindings to match other volumes in their libraries. Anna Atkins self-published British Algae on pages that were individual and unmarked, and this resulted in considerable variations from one copy to the next. No one knows how many copies Atkins produced, but 14 complete or sufficiently complete copies are known to exist today. Together, these total more than 6,000 cyanotype photograms, each produced on a hand-coated sheet of paper, exposed one by one to sunshine. The production of these thousands of prints demanded a full decade of tremendous effort from Anna Atkins, who dedicated herself to creating British algae between the years of 1843 to 1853. Several hundred more cyanotypes of ferns, other plants, feathers, and lace are continuously being found, and several copies have emerged in the past few years. Not surprisingly, Anna Atkins was largely forgotten shortly after her lifetime. William Fox Talbot mentions her as a lady some years ago who photographed the entire series of British seaweeds and most kindly and liberally distributed the copies to persons interested in botany and photography. Because it is one of the most simple and easy photographic printing methods to master, and also cheaper than expensive silver or platinum-based photographic processes, cyanotypes became very popular amongst amateur photographers and also as a cheap proofing method. It is the only method from the first decade of photography to have survived in active use well into the 1950s. That is because this method was embraced in architecture and engineering firms as a means of copying drawings and plans, and they were called blueprints. Cyanotypes are created by coating a sheet of paper with a light-sensitive solution. Instead of silver salts used in most photographic methods, cyanotypes are based on the light sensitivity of iron salts. The original formula used potassium ferrocyanide and ammonium ferric citrate, but there are many variations of this solution. The coating has to be applied under dim light, It creates a yellow-greenish layer on the paper and should be left to dry in the dark. Once the paper is dried, either a negative or a partially or fully opaque material is placed on top of the paper and sandwiched against a sheet of glass. But in Anna Atkins' time, she used thin sheets of paper made more transparent by oiling and waxing. She also might have used a piece of mica, the only available rigid, transparent substance in those days. After exposure to light, the sensitized paper is washed in water to remove the unexposed chemicals. The ferric salts in the areas hidden from light remain unchanged and are dissolved away during washing, while the areas exposed to light turn the ferric salts into ferrous salts, also called Prussian blue. The bright blue color emerges as the print dries. The cyanotype is a one-layer photographic structure. The image is embedded in the fibers of the paper and produces a print with a matte surface. When a negative is used, it creates a print, and when flat objects such as flowers, plants, and algae are used, it is called a photogram. Cyanotype is a simple and elegant method involving only two chemicals that can be applied to ordinary writing paper with a brush or sponge and then exposed directly to the rays of the sun. The only other element needed is water, which brings out the blue color and also fixes the image. A cyanotype print is made fully permanent by the very procedure of washing it in plain water. Identifying cyanotypes sometimes can be challenging because the formulas vary so much and also the paper substrate used for printing. So the tonal variations on cyanotypes can have shades of blue that go from light blue and gray blue to a bright and intense navy color. And you can notice this on Anna Atkins prints. The highlights of a cyanotype photograph are light blue or white, and the dark areas are in various intensities of blue. Most cyanotypes present a matte surface in both the blue and white areas of the image, even when tilted and observed under a raking light. Signs of hand coating may also be visible in the image or hidden under a framing mat. Fading, bleaching, and dispersing is how cyanotypes are most often damaged. Fading may occur on cyanotypes when Prussian blue is exposed to sunlight. The photochemical reduction caused by visible and UV lights makes the image lighter over time. But surprisingly, cyanotypes that have been exposed to light and slightly faded can recover image density once returned to dark storage and provided some airflow. A recent study at the National Gallery of Canada confirmed that historic cyanotypes can be safely displayed under properly controlled gallery conditions. Several historical cyanotypes, including images by Anna Atkins, were monitored. Even after a cyanotype had faded by moderate daylight exposure, recovery of the image density in the dark will be completely reversed after 4 or 5 days. At an illumination of 50 lux, the rate of oxidative color regain may equal the rate of fading, so that no perceptible loss results. Most of the fading of a cyanotype occurs within the first hour of a typical daylight exposure. At first, the midtones in a cyanotype image drop 10 to 20% of their density, but thereafter the fading tapers off to a constant density. Bleaching comes from alkaline hydrolysis, which occurs when the cyanotypes are in contact with any alkaline substance. The Prussian blue pigment is rather stable in neutral or acidic environments, but it quickly decomposes by the presence of alkaline materials such as ammonia and sodium carbonate. Cyanotypes should therefore be maintained in mildly acidic conditions of a pH between 4 to 5, even though this is not deemed ideal for the preservation of paper substrates. Conservators should be prepared to prioritize the preservation of the image over the paper. That is because the cyanotype images are destroyed more rapidly in an alkaline environment than cellulose paper is damaged on a mild acidic space. Dispersion happens when the pigment Prussian blue has contact with water and it is physically removed from the fibers of the paper. No chemical reaction takes place in dissolving the Prussian blue pigment. Instead, the tiny nanoparticles that are insoluble in water, if not securely trapped inside the cellulose fibers of the paper, can be washed away. This tendency to disperse easily in water is called peptization, a loss that is irreversible. If water is necessary to remove a mount or for essential preservation treatment of a cyanotype, only the verso of the print should be float washed, and the image side of a cyanotype should never be immersed. Another solution is a damp pack treatment, which avoids water immersion altogether. Cyanotypes should breathe. When on exhibition, choose a deep window mat to allow air to access the surface of the print. For the same reason, an archival opaque paper that protects from light but allows contact with air is preferable over polyester. Polyester should be avoided for storing cyanotype prints exactly because of its opposite properties. It exposes the print to light and prevents air from having contact with the surface of the paper. Cyanotypes fare better in a slightly acidic oxidizing environment. No deacidification treatment should ever be applied in an attempt to preserve the paper substrate of a cyanotype. And for the same reason, no adhesive should be applied on the verse of a cyanotype, since most adhesives are alkaline and can easily migrate through plain paper, causing discoloration on the image on the rectal side of a cyanotype. Buffered materials with chalk became standard conservation practice in caring for all works of art on paper and for the storage of all photographic materials since 2007. Buffer fine art papers and mount boards function as a basic reservoir to neutralize any excess acid from the environment or from the object itself, and to protect the chains of cellulose molecules should break and consequently make the paper brittle. This process is also known as acidic hydrolysis. But it is now confirmed that cyanotypes should not be mounted or wrapped in buffered materials. Only acidic paper provided any protection to the images, even as it posed risks to the paper they were on. Cyanotypes should not be stored with other photographic processes that might emit alkaline vapors. The most important element that you should be aware is that the azo copies, which sometimes are also blue, are the most threatening to cyanotypes. So identifying the azo copies from cyanotypes before storage is fundamental. Diazo copies have ammonia in their processing, which are the most damaging element to a cyanotype. How a freshly made cyanotype was truly washed has a direct impact on how sensitive to fading a print will be. If you ever venture in creating your own cyanotype with one of today's widely available kits, the simple precaution of washing the prints thoroughly could improve the archival qualities of a unique piece of art. I hope you'll get to make some cyanotypes yourself one day. Thank you.